So, GCSEs, we had to do all of our core subjects, so English, maths, sciences, that kind of thing. And then I took history, because I was interested in it. We had to do a technology, and I chose music, because I'm not really very hands-on technological, but music I could do. And I did art, because I wanted a nice sort of balance of a bit of everything. And then at A-level I took English language, biology, chemistry and maths. So my biology and chemistry because I knew I wanted to do science. My maths to sort of help out with my chemistry and biology. And English language because it's quite technical and interesting, and I couldn't take literature in the same blocks the way that they'd actually worked out, and I didn't think I would have time to read all the books I needed to read for English literature. But I absolutely love English language, and I thought it might come in handy for writing essays, writing papers, reading papers, that kind of thing. So having a good understanding of English language would be quite helpful. Obviously, because I carried on studying biology and chemistry, my biology and chemistry from A-level were really helpful. Even though I was mostly doing a biology degree, having that chemistry to sort of help out with like the little bits of chemistry that creep in, that was really helpful. The maths AS level that I did was very helpful. That was fantastic, because when you get to things and you start doing matrices and vectors and things like that, I would have been completely clueless if I hadn't at least heard those words at A-level. And English language, you know, just staying in the habit of writing essays and that kind of thing. At university there's quite a lot of writing essays and writing lab reports and things. So having that experience at A-level of still having to write essays for my subject, that was quite helpful because I was still in the habit of doing it, and I could, you know, write 2,000 words quite happily, so they were really good. Problem solving, because you need to really understand what you're doing, and if you can't fit all the little pieces together, you have to be able to think through your problem and think through your experiment. And then there's just little things like having a good eye for detail. So as long as you can pick out the important things in your instructions, in, you know, papers that you're reading, all the information that you'll get given at the beginning, that's really helpful. Having a good head for numbers is quite helpful as well. I mean, it's not essential because it's not like you do a lot of really complicated maths, but it definitely helps out. I'm in my first year of my PhD, so after you do your degree at university, I'm doing postgraduate work. What I'm doing at the minute is I'm trying to find a new drug for tuberculosis. So I have a target protein from tuberculosis that I'm trying to find molecules that will fit and inhibit this protein. Sort of like you have your enzyme, your substrate. In this way I've got my protein and my drug. So what I'm trying to do is I'm using software to run different versions of little molecules to see how they fit and how they influence the shape of the protein. It's very early days at the moment, so we're just trying to get all of the things in place. But at the end of it, hopefully I'll at least have something and say, okay, this might work, and then we can give it to drug developers to properly look at it and get it as best as possible. Well, the main benefit, hopefully, will be another drug for tuberculosis, because the way that treatment for tuberculosis works at the minute is that there are a lot of antibiotics that you take over 6 months. So you have this big cocktail therapy. So if you contract it, you have to take antibiotics, 4 different antibiotics over a course of 6 months. If they don't work, and you have resistance to these antibiotics, you have to start going down this massive list of other ones that you try after that. And they're not as good, and they don't work as well, you have terrible side effects. So trying to improve these ones is like a really good idea. So that's what I'm working on, trying to make sure that these drugs work as effectively as possible to try and combat the resistance. Hopefully, if all goes to plan, we'll be able to make the treatment for tuberculosis a lot more effective and try and eradicate it, because it's a serious problem, especially in Africa and the Far East. It would still be a cocktail, because what I'm looking for is a co-drug, so it's something that would work in combination with something else. It would just mean that you wouldn't have to take as many drugs for longer. So we could try reduce it from maybe a 6-month treatment down to a 3-month treatment, or instead of taking 4 antibiotics, you could only take 3 or 2. So it's just trying to make it a lot easier, because one of the reasons that resistance is such a problem is that people don't necessarily take their drugs the way they're supposed to, either because they don't want to or because they can't. If you don't have that access, you can't take 6 months worth of drugs. It's quite simple, especially in Africa where this is a massive problem. Getting your hands on the drugs in the first place is very difficult, but then 6 months treatment is very expensive. So if we can make this really cheap, really quick, and a lot more effective, then it just benefits everyone. It's a really big problem. There's tuberculosis, which is the main kind, and then there's what we call multi-drug resistant tuberculosis, which is just a strain that is resistant to at least 2 of the main 4 drugs that we use. If that happens, then you start using second-line drugs. But there's also on the rise what we call extremely drug-resistant tuberculosis, which is resistant to a lot of the antibiotics that we use, and that's a major, major problem. One of the primary reasons is that this happens a lot in HIV patients as well. So it's never really the HIV that kills you, it's whatever manages to take advantage of your suppressed immune system. So it's a serious problem that TB is actually one of the biggest bacterial killers in Africa in HIV positive patients. So really, drug resistance is one of the main problems in TB at the minute. All of these things that are bonding and molecular energy, it's all about how things just relate to each other. The classic example that you learn at A-level is the difference between graphite and diamond. And graphite is in sheets, and you have bonds that keep the carbon together, but you've got intermolecular bonds that keep the sheets together, whereas diamond is different. And I work with crystals as well, which is you have the bonds between atoms, but you also have how things relate to each other in space, which are your intermolecular bonds. And I mean, you apply chemistry to everything in life. When you boil an egg, you are actually denaturing the proteins in the egg white, which then change how they relate to each other, and you go from having this runny egg to a nice solid white. So it's how everything is interrelated, and everything in the universe comes back to atoms and bonds and energies. So I think having a good understanding of that, I find it really interesting. Industry is all about business. So basically you're out to make as much money as you can without expending lots of resources. So whatever you're doing, if you have your reaction at equilibrium, then you're reducing waste. So you don't have to use as much resources to get the desired effect. If you've got a nice balance, you don't just chuck everything in a barrel and hope that you get a little bit at the end of it. You can fine tune it so you know exactly how much you have to put in and exactly how much you're going to get out, without expending a lot of time or energy or resources. And at the end of the day, you can make a profit on what you're doing. I like research because I'm doing something new every day, and I think that that's one of the most exciting things, because it's something that no one else has ever done, and I get to be my own little expert of my own little tiny area of research. And I think no matter what you do, whether it's chemistry, biology, physics, engineering, maths, you get to do something and push the boundaries the way that no one else has done before. And it's hard work, and it's interesting, and it's challenging. I studied as a biologist, but I do a lot of chemistry. I'm doing a lot of computer work at the minute, so I'm doing a lot of simulations, I'm doing a little bit of physics. I have a bit of experience with X-ray crystallography, so I work with big X-ray diffractometers, so that's physics, and I understand how it works. That's a little bit of engineering, and maths comes into everything. So I get to do lots of different things, and every day is different, and it gets me out of bed in the morning. So I think research is really rewarding and fun, and it's a challenge, which I really enjoy. I think pick something that you're going to be interested in, because it's all very well saying, oh well, I'm really good at that bit of science or that kind of engineering, but if it's not something that you really enjoy and that you're going to want to do for the next 3, 6, 10 years, then you're not going to want to get out of bed and do something new today. And I think if you find something that you are really passionate about, you can really do well. I think there's nothing worse than picking something just because you're good at it but you don't enjoy it. So pick something that you really enjoy, but also pick something that you're good at. I mean, that's great. Read everything. I mean, read the news, read newspapers, read the internet, read blogs that people write about what they do in their research, because you will pick up little bits of things. You pick up the type of language that they use, how they talk about their research, you talk about what they're doing. It can influence your ideas. Don't be afraid of getting things wrong or failing, because 90% of the time what you do in science particularly, it never works. That's the secret. I mean, for every big success there are 95 times before that it didn't work. So never be afraid that if something's not worked, you just go, right, okay, that didn't work, what went wrong, fix it. So don't be afraid of stumbling a little on the way, because that's how you learn. That's how everybody learns. Trust that you're going to be good at it. Trust that it's something that you really want to do, and go for it, because if the world needs people who are going to push the boundaries and be really passionate about what they do. So if you find something that you're passionate about, just go for it.